Welcome back. In the previous sections, we have discussed in depth work done in two broad areas, table extraction and table understanding. In this section, we will show how these two can be combined into a single end-to-end pipeline for table processing. To start off, let's walk through an end-to-end example. Let's assume that we want to help financial analysts analyze the financial statements of Air Canada. Starting with the corresponding PDF documents, we first utilize table extraction techniques to recognize where the tables appear in the input documents. That is, identify the table borders. Then, for each identified table, we identify the table structure, conceptually the grid of the table. Once we know the table grids, we can use table understanding techniques to identify and annotate cells with all the semantic information that pertains to them. As we have discussed in the table understanding part, this semantic information can be derived from multiple places. So it includes information that can come from table regions, such as column headers and row headers. Information that may appear in other places within the table, such as currencies, scales, etc. Information that may appear within the broader document, such as table and document title. And finally, information that may appear even outside the document, such as external knowledge bases. The output of this process can be thought as a set of all these semantic cell annotations. Here you can see one particular way of representing the output of table understanding. However, it's important to note that the particular format does not matter. What matters is the type of semantic information that is included, such as row headers, column headers, table and document title, external entities, etc. This is the information that can then be passed into downstream applications for further processing. Downstream applications could, for instance, in this case, include creating a financial knowledge base, creating a question answering system for financial tables, and many others that we will discuss in the following section. But before going there, I wanted to spend a few minutes to discuss the interaction between these two components, the interaction between table extraction and understanding, as there are a few important points that can be very easily overlooked. The first one has to do with what is included or should be included in the output of table extraction. Since the output of table extraction is the input of table understanding, table extraction should maintain, in addition to the contents and the structure of the table, also any formatting information that could be helpful for table understanding. This includes both more standard styling information, such as, for instance, bold information, text and background color, etc., which can be particularly useful to differentiate headers from body cells, but it should also include less standard styling info, such as, for instance, indentation information within the cells, which can be seen on the left, which may help in particular with identification of hierarchical row headers. So the first takeaway point is that table extraction developers should make sure that they maintain in the output of their system as much formatting information as possible if this formatting information could be used in table understanding tasks. The second point has to do with error propagation. Even the best table extraction algorithms, they may make mistakes. For instance, they may split cells, which is what happened with this total for each derived cell that was split into two different cells. Or they could merge cells. For instance, this is what happened with the squirrel and deer cells that were merged into one. And since table understanding depends on the output of extraction, these errors may affect table understanding tasks. For instance, in this case, table understanding will look at this 7 and 4 as a single cell with the associated row header of squirrel and deer, instead of treating them as two separate cells with the corresponding headers. Hofswell et al. Have looked at this problem, and they tried to classify the different types of errors that may happen in an end-to-end table processing pipeline, and also explain how they may affect downstream tasks. For instance, when it comes to detecting tables, two possible errors is that a table may not be detected, or something that is not a table can be detected. And this could, for instance, impact what comes out of table understanding as well. Therefore, the second takeaway point is that if someone is working in table understanding of tables that have to go through the table extraction process, for instance, tables that come out of PDF documents, then they should not assume that the table structure is correct. At the very least, when working with those tables, we should be aware of table extraction errors, if not, do something to mitigate them. Since a lot of work in table understanding has been done on tables whose structure is known in the input documents, for instance, web tables, it is unsurprising that not a lot of work has been done in this area. However, in both business and scientific documents, I think that this interaction of extraction and understanding and how one can affect the other is important and could definitely benefit from additional work. With that, let me wrap up this section and hand the stage over to Marina, who will be talking about applications of both table extraction and table understanding. Thank you.